Okay, in this lesson, I wanted to show another ZIO Streams error handling example. And in this one, I want to show a few more things. I have a bit of a long description here, but it's really not too bad at all. We're going to demonstrate advanced error handling in ZIO Streams. We're going to process HTTP requests with different failure modes. I'm going to implement a custom retry strategy for certain timeout errors. I'm going to show error-specific handling for malformed requests. Provide graceful degradation for server errors. As we go through this, we'll highlight ZIO's composable error recovery mechanisms and use schedule combinators and some tap calls for monitoring retry progression. So while that sounds like a lot, this description might be longer than some of the code we're about to look at. So we begin with the usual object, some name, extend ZIO app default. And then what I do here is create a Z stream, and as you can see, it contains, 6 strings here that are supposed to simulate different types of HTTP requests. And you'll see that some of them should succeed, like these first two. And then this one is an attempt to indicate malformed JSON. Then we have another successful one. This one indicates a timeout, and then another successful one. So for the error processing, this one and this one will be the ones to keep an eye on. And again, I call this value request stream right there. To work on this code down here below, as you'll see here and here, I want to create this final case class. It's named HTTP error. And you can see that it's going to have a code, which is an int, and a message, which is a string. And I don't believe I ended up using these functions. So I could delete these functions, but I'll just keep them in there and you don't have to worry about them too much. The big thing is I just wanted to create a class for the errors that we're going to run into down here. And again, we're going to have an error code and then a message that goes along with it. So if we scroll down here, you'll see what I mean. So process request is a function that's going to take a string as input. It's called request. And then it's going to return a ZIO value here. And you can see from the ZIO value, any old requirement will do. We don't have any special needs there. The possible error here is going to be this HTTP error here. I actually started off here as a tuple 2 with an int and a string, and I thought, well, that's not very clear. I'd rather give this a name. So that's where this class came from right there. So this is the possible error, and then the success value is going to be a string. So what's going to happen is we are going to work on this stream. So if you imagine getting this first string right here as input, we'll be processing that one in here. So we'll do a match on that request and we'll say, well, does it contain malformed? No, it does not. Does it contain timeout? No, it does not. And then we look at the success case here and we say, well, if it contains get, which it does, then we'll return a 200 OK, and then we'll return the string and say that it was processed successfully. Now in other cases, like this one with the malformed JSON, when that one comes in here, we're going to say, does it contain malformed? Well, yes, it does. So here we'll do a ZIO fail on that one. And you can see that's where I use the HTTP error class, and I give that one an HTTP 400 code, and then the string is bad request malformed JSON. And then for this timeout one here, it's going to fail on this line right here, which says it contains timeout. That one's going to be an HTTP 408 error, and you'll see the string is request timeout operation timed out. So that's the way that one's going to work. And then we have a catch-all case down here. If I missed anything, then we would have a HTTP 500 error, which is an internal server error. I don't think I have any of those, do I? No, everything else should succeed. So as we're processing this, we'll see success, success, failure, success, failure, success. And that'll be coming out of this process request function. And then when we come down here, we're actually going to do processing of the stream using that process request function. And the intent of this code here is to start showing some of these error handling approaches that I talked about in the comments above. So process stream is going to be a Z stream in the end. And you can see it has no requirement environments, cannot throw an error, and it will return a string as it's going along processing. So then we take the request stream, which is this stream right there, and we say, well, what we want to do is map ZIO on that. And if you recall, map ZIO is just like map, in that it maps over elements of the stream. And the only difference is that we use a specified effectful function. And that just means that this function that goes from here down to here is an effectful function. which just means that we return ZIO types as we go through the code here. So you see a ZIO succeed, and ZIO succeed right there. Okay, so we have the request stream, we do the mapping, and then we get the request string right here. So if you think about that again, this is one string at a time. We're getting this one, and then we get the second one, then we get the third one, and so on. So that's the way this code is going to work. And then we're mapping over that. And what we do is we call process request, which is this function right here. So we say process request on the current string. And the way this code works right here is it's calling this, and if that succeeds, it's just going to return that string value right there. And if it fails, that's where we're going to deal with this catch-all area down here and that HTTP error that I showed up here. So if you imagine the first string, maybe I can even move that data down here. It might be a little bit easier to look at that way. Okay, so we get that first string right here, and that comes into process request. So then this code from here to here is going to succeed. We'll get the 200 value out of there. And then we come to the second line, that's going to succeed. So again, we'll get the 200 line coming out of that, by which I mean this line right here, that ZIO succeed right there. Then we come to the third line with the malformed JSON. And that's the one that's going to hit this code right here. And that's going to yield the ZIO fail and that HTTP error. So that's going to be in the error channel right there. So now what happens is instead of the result coming out of this area right here as a success value, it's coming out of the error channel. And now we're saying catch all the errors in the error channel and handle them in this code right here. So that's where we are now once we start working on this malformed JSON. And the malformed JSON is going to return an HTTP 400 error right there. So what happens inside of catch-all is it looks at this case and it says, do you have an HTTP error with a 408? Well, no, we don't. We have an HTTP with a 400. And oh, okay, that happens to be the next case right here. And that's because we transformed this string into an HTTP 400 error. So the code says, okay, I match on the 400 with a message. So what I'm going to do is just yield this ZIO succeed right here. And that's going to be this 400 bad request, skipping the malformed request. And that comes out as a string out of the process stream right here. So that's how, inside of catch-all, how we catch that 400 error and transform it into a ZIO succeed value. And then if we come back and look at the data, this next line right here is going to succeed, so that'll be a 200. And then the next line here is going to fail. That's a timeout error, and that is going to fall into this code right here. And you can see that inside of a ZIO fail, that's going to return an HTTP error. That is going to be a 408, and it's going to have that request timeout string right over here. So an important part right now is that it's an HTTP error, and it has a value of 408. So now when we come back here, we're inside of the catch-all area, again, right here. And now we do come down to this first HTTP error case, and we do match that one right there. And now we're going to handle this timeout error by doing a retry attempt here. So we're saying that for this HTTP timeout error, what we want to do is that 3 times we want to retry every second to do the following code. Okay, so the first thing we do is this log info, and we're going to say there's a timeout error. And that log information will appear over here. And then we have the and then operator right there. So it says do the logging and then go ahead and try to process that request again. Notice how we have process request right there on the request string. So go ahead and process that request again. And then we do the retry on that attempt right there. Then we have our retry schedule, which is this value right there. So that's actually doing the retrying. If I got rid of that tap output, that would be a little bit easier to read. But the nice thing about this tap output is it's going to say, oh, okay, I completed retry attempt number 1, number 2, and number 3 for this request right there. So that's why I left that in there. But again, if you took that out of there, that code might be easier to read. But I'll just leave that in there. And then what happens is after this retry schedule right there, that's going to fail because it will never succeed on this. It's not like we're calling a new function or making a web call. We're actually getting new data. We're still getting the same line right here of code. So it's going to fail 3 times. And then what happens is once that fails 3 times, it'll come down to this catch-all case right here. And then we'll see this message inside of a ZIO succeed. It will say failed after the retries and then the timeout right there. So again, just to stress that point, here we're just dealing with static data. So this is definitely going to fail 3 times. But if this was some other type of data source where we could say, okay, I am calling a web server or a web service and I may get a different result when I retry, that's when you'd actually want to use this type of code right here. And that's what I'm trying to demonstrate. Okay, and then the last value up here is going to be this delete line right there. So it's going to succeed inside of here. You won't even have to worry about the catch-all. It's just going to come out of there with a value. And you can see that right there. It's going to come out with a 200 value. So that one's going to be just fine. So as I mentioned, we will never hit that code right there. And therefore, we will never hit this code either. But in the real world, you might hit that. So I wanted to show how to handle those. The other thing I wanted to show here, I have a note here. Earlier in the code, I had a tap input and a tap output. And I just wanted to mention the difference. The tap input executes the given effect every time the schedule receives an input. And again, I deleted that code up here. But tap output executes a given effect every time the schedule produces an output. So in our case right here, that's when the schedule is going to issue a retry count. And this lets us observe the progression of retry attempts. So we're going to see that in the results over here. And also down here, I have, I think it's an old note now, but I was showing different ways to do scheduling over here. So I had some notes that you can use schedule, recur while, recur until, while input, and until input there. And then what happened was I ended up changing this code. So now I just use this retry schedule that you see with the recurs and the spaced and the retry here. So these were some notes about different ways I was handling this code initially. And those are a little out of date, but I will keep those there for your reference. And then finally here at the end, we have the ZIO run value. And then we just take our process stream, which is this one right there, and run for each. And then we're going to print each line as we go along right there. So that is the code right there. Take that, move that over here. This one's named 135. So I'll call Scala CLI and then 135, and we'll run that code. So you can see from the results over here how that worked. We have a 200 result for the first value. We have a 200 result for the second value. The third one was this malformed JSON one right there. So we got a 400 bad request, skipping the malformed request right there. Then we got another okay one with that 42 right there. Then we come to this timeout one right here. And that's where we had probably our most interesting code right here with that retry schedule. So you can see we got a request timeout, operation timed out for the request, and then the get/API/orders timeout right there. And this part is coming from the log info right there. And then you saw the retry attempts down here coming one at a time. And those were coming from our tap output on the retry schedule. So as the code was retrying this string right here, it came over here, it said, oh, okay, I'm trying again, and I'm trying again right there. And then finally, when it fails at the end with this catch-all right there, then we have failed after retries timeout, and that's this line right there. So at that point, it moves on from this timeout string right here, and then it goes to the very last one, and you get another 200 okay delete on that one. All right, so I don't think there's anything else to show there. So we'll go back to the comments here and say I wanted to show some more advanced error handling with ZIO Streams. We got that. We're processing HTTP requests with different failure modes. And we are definitely doing that here and in this code here as well. We implemented a custom retry strategy for timeout errors. We did that. Showed specific error handling for malformed requests. Provided graceful degradation for server errors. So we did that both with the request timeout code and also with the internal server error code right there. Definitely highlighted ZIO's composable error recovery mechanisms because we were doing all kinds of composition right inside of here. And then we use schedule combinators and tapping for monitoring retry progression. And I showed that here where we're doing tap output on our retry schedule inside of the retry call right there. So as always, I encourage you to get this code out of GitHub, and you saw the file name right there. It begins with the 135. So get this out of GitHub and work on it, play with it. and create all kinds of experiments inside of here to make sure you understand how everything works. And maybe the biggest one here is how we're using catch-all right here to handle possible errors coming out of process request. And in this particular case, the retry schedules that we're doing right here. So again, I hope this has been helpful.